The curve C has the equation y equals to x squared bracket x minus 6 plus 4 over x where x is greater than 0. The points P and Q lie on C and have coordinates 1 and 2 respectively. Show that the length of PQ is 170, root 170. Okay, P and Q lie on C and have coordinate x1 and 2, so therefore you got to find what is y. So let's find that. When x equals to 1, y equals to, that's x cubed minus 6x squared plus 4 over x. So this is 1 cubed minus 6 times 1 squared plus 4 over 1. So that's 1 minus 6 plus 4. That's negative 5 plus 4, which is negative 1. Okay, so let's say this is P, 1 minus 1. Let's find what's Q. Q is x equals to 2, so y equals to 2 cubed minus 6, 2 square plus 4 over 2. And this is 8 minus 6 times 4, 24. 4 divided by 2 is 2. So that is 28 minus 24, 24 minus 8 is minus 16. And that's plus 2. And that is minus 14. Okay, so therefore Q is 2 minus 14. Okay, we got that. Now show that the length of PQ is 170. So let's label them x1, x2, y1, y2. So PQ would be 1 minus 2 square plus minus 1 minus minus 14 square. Okay, oops. So that would be 1 minus 2, which is negative 1 square, and negative 1 minus minus, so that's positive 14. So positive 14 minus 1 is positive 13 square. So that is 1 square minus 1 square is 1, 13 square is 169. Therefore it is root 170. Okay, that's shown. Okay, next, show that tangent Q, so tangents to C and P, tangents to C at P and Q are parallel. So you have a curve, and these two curves, okay, there are two tangents. One is at P, on which is P is on the curve. Okay, so there's a tangent at P, and then there's a tangent at Q. Okay, basically on the curve. Okay, so these tangents are basically a line which is perpendicular or just touches at one point on a curve. So let's find the coordinate. Okay, we already have the coordinate 1 minus 1, and then Q2 minus 14. And what do they want? Show that the tangent to C and Q are parallel. Okay, so tangent to C and Q. So to find the tangent, when we differentiate a curve, okay, the gradient that you're getting is the tangent gradient. So let's write down the equation of the line. Y equals to, we have x cubed minus 6x squared, x cubed minus 6x squared, and plus 4 over x, but I'm going to change it to 4 to the power of negative 1. Okay, bring the x to the top so that it becomes the power of negative 1. It's easy for us to differentiate. Now let's differentiate this. Dy over dx equals to 3x squared minus 12x minus 4x minus 2, which is 3x squared negative 12x minus 4 over x squared. Okay, remember, whenever you differentiate at any point, okay, differentiate a curve at any point, the gradient that you are getting is a tangent gradient. So now at P we have x equals to 1, and at Q we have x equals to 2. X equals to 1 at P. Let's find out what is the gradient, tangent gradient. So 3, 1 square minus 12 times 1 minus 4, 1 square. So this is 3 minus 12 minus 4. 3 minus 12 is negative 9. Negative 9 minus 4 is negative 13 or minus 13. At Q we have x equals to 2. So dy dx, or the gradient, tangent gradient, is 3, 2 square minus 12 times 2 minus 4, 2 square. So this is 2 square, which is 4. 4 times 3 is 12, minus 24, and 4 divided by 4 is minus 1. So this is negative 12 minus 1. Yes, we are getting minus 13. Therefore, the tangent gradient at P and Q are parallel due to having the same gradient. Okay, I think you get the idea. Okay, next, C. Find an equation for the normal to C at P, giving you answer in form of ax plus by plus c equals 0, where a, b, c are integers. Okay, a, b, c are integers. So find an equation for the normal to C at P. Okay, normal. If I have a curve, if this point is, this is the tangent line, then normal will be exactly perpendicular to the tangent. Okay, so this will be normal line. Okay, normal line which will be perpendicular to each other. So we already have tangent gradient at P to C is, what is the tangent gradient? At P we have minus 13. Okay, we have minus 13 is minus 13. And remember, if it's perpendicular, the tangent, the gradient of tangent, m1 for tangent, or times by m2 for normal, will give you negative 1. And since the tangent gradient at P is minus 13, so the normal gradient must be positive 1 over 13. Okay, positive 1 over 13. And what is the coordinate at P? We have coordinate at P x1 and y minus 1. Okay, x1, y minus 1. Okay, so coordinate P x1, y minus 1. Okay, that's it. Now we can form the equation, and m equals to 1 over 13. So therefore y equals to mx plus c. Y is negative 1, m is 1 over 13, x is positive 1 plus c. So negative 1 equals to 1 over 13 plus c. Therefore c equals to negative 1 minus 1 over 13, which in turn will give me minus 13 minus 1, minus 14 over 13. Okay, that's C. Now you have to change it into this form. Okay, the equation has to be in this form. So y equals to m 1 over 13 x minus 14 over 13. Now if I times the whole thing by 13, times this whole thing by 13, you will get 13y equals to x minus 14, but it has to be equals to 0, so bring everything over this side. So you have 13y, okay, the ABC are integers, so Okay, I can bring it over the other side. So x minus 13y minus 14 equals to 0, or you can even write 13y minus x plus 14 equals 0. Okay, both are accepted. There you go.